Welcome all to the channel. This is a channel where we make statistics simple and easy to everyone to understand it. And if you've not subscribed to this channel, kindly hit the subscribe button and share the videos for you to learn more. So today we are going to learn about dependent t-test. It's also known as related or paired t-test. Why? It is because we are talking about the same group or the same set of data that has been measured twice. In this case, we usually want to measure what is the influence of an intervention within the same group. In our case here, we have animal ID. We have 20 animals from 1 to 20. And then we have their first weight, phase 1, before the experiment was carried out. And then we have phase 2 after the intervention that was done. And of course, we have our hypothesis. Our null hypothesis is that the mean of phase 1 and phase 2 is equal, and our alternative is that the mean of phase 1 and phase 2 is not equal. So what do we do? In our Excel, at the toolbar here, we have data. So you go to data. Once you are in data, at the far end, you have data analysis tool pack. So you click data analysis. In these tools, you go to this t-test, but now remember we have paired two sample means. So paired two sample means, and then you click OK. So we have a new window pops up. In this window, we are expected to input our data. Variable 1 range, I prefer putting variable 1 range as the aftermath of the intervention, which is phase 2 weight. So you select phase 2 weight. Variable 2 range, you'll put phase 1 weight. And then hypothesis means. So hypothesis means is that difference is that our hypothesis is that there is no difference between these two. So if there is no difference, our hypothesis mean is difference is 0. And then you check this box label to tell Excel that our first row are variable names. So, and then where do you have the output options? Let us just paste them within this worksheet, and let's say our results be pasted from this end. Say our results to be pasted from this end here. So click OK. Great. So we have our results here. So once we have our results here, so this tells you the up to this point, it gives you the summaries of both over phase 1 and phase 2. Phase 2, it tells us that we recorded a mean of 74. And the phase 1 was 59. So there was a mean difference. Actually, it increased. So there's a mean difference. But was it significant? So if it is significant, this is where we come at this level. So we need our t statistics and our two-tailed and our p-value here on this other end. So in our p-value, what we are going to do here, we can say that our significance level is 0.05. So if our significance level is 0.05, we check on our, because it was two-tailed. Our case here, it is two-tailed. Two-tailed meaning that we are trying to check if there's significant difference. We are not talking about an increase or a decrease. We're talking about significant difference. And what is the p-value related to this? The p-value related to this is 0.0003, which is less than this. So given our thumb rule, since our p-value is less than the significance level, we reject our null hypothesis and conclude that there was significant difference between there was a significant difference in the mean of weight in phase 1 and in phase 2. So that is how we are going to interpret our results. Alternatively, you can check the t-test statistics here and the critical value here. So again, you'll find that our t-test statistics here, our t-statistics is higher than this, so we still reject the null hypothesis. Thank you.